Hi guys, it's Miss Hill again, and here we are again with our linear functions. And today we're going to talk about writing our linear equations. And you can use any of the forms that we've talked about previously. I know most of you prefer to write your equations in slope-intercept form, so that's what we're going to kind of focus on. But I also want to point out how to use slope form, or the point slope form, and then we'll also eventually be getting into how to write those equations in standard form, because that will be helpful later on. So if we're going to write an equation given just the slope and the y-intercept, that's our first option that we're going to look at. Obviously you're going to plug in your slope for m and the y-intercept for b. And I think we're pretty good with that based on everything that you've done so far and reviewing everything from Math 1. Now if you're given the slope and a point, then you have two options. The first option, you can use your slope-intercept form, and you can start with your slope, plug in your values for x and y, and then solve for b. And then you'll be able to have your slope and y-intercept to plug into y equals mx plus b. Now, I'm very partial to using the point slope form just because you can plug in the slope for m, and then you have your x1 and y value x1 and y1 values, that you can plug in for the point. And then once you're in point slope form, you can either leave it as is, you can solve for y so that it's in slope intercept form, or you can change it to standard form. It's very easy to switch over to whichever form you prefer. Another option that we're going to be looking at is given 2 points. If you're given 2 points, remember you can find your slope by saying that m is equal to y2 minus y1 over x2 minus x1. And then you can choose one of your points from there once you have the slope, and just like we did before where you're given the point and the slope, you can either plug in the slope with one of your ordered pairs to find the y-intercept, or you can plug it into point slope form and use that to get it into whichever form you want. Then the last option that we're going to be looking at is from a graph. You can either find the slope and the y-intercept from the graph, and given slope and y-intercept, hey, we already have our equation in slope-intercept form. Or if you have 2 points, you're not quite sure what the y-intercept is, then you can use the given 2 points option where you find the slope, and then I personally would use the point slope form, but you can also use the slope-intercept form and solve for b. Any of those options work. Now keep in mind, we're going to have some equations or some problems where we're asked to find the equation of a line that's parallel. Parallel lines have the same slope. Perpendicular slopes, they're going to have opposite reciprocals. So you want to keep that in mind as we try to find equations of lines that are in standard form that might be parallel or perpendicular, or we could write it in slope-intercept form and have them be parallel or perpendicular to a given line. So let's put all of that into practice. I know that was a lot of information, but we have lots of examples here. So if we want to write an equation in slope-intercept form, so our y equals mx plus b. If we're given the slope and the y-intercept, that's exactly what we want. We can simply plug it in. Y equals our slope, which was -3, times x plus our y-intercept, which was 4. That's about as easy as it can get. Now for number 5, this one's going to take a little bit more work because we have the slope and a point, -4, -2. So for number 5, I'll show you the 2 options. So number 5, those of you that are very partial to your slope-intercept form, that means that we're going to take our slope of 1/4. So if our slope is 1/4 and then we have our ordered pair at -4, -2, we plug those in and solve for b. So we'll say -2 is equal to 1/4 times -4. Well, that's -1 plus b. So when I solve for b, I'm going to be adding 1 to both sides, and I get -1. So now I can take that and say that we have slope of 1/4. Y-intercept is at -1. Y equals 1/4 x minus 1. The other option, given point and slope, is to use our point slope form, y minus y1 equals m times x minus x1. So using this form, we still have our slope of 1/4. We can plug that in. But we have our ordered pair that was negative 4, -2. So we're going to say y minus our y1 value that was -2, so y plus 2 is going to be equal to x minus my x1 value. Well, my x1 value was -4, so we're going to make that a plus 4. So now that I'm in point-slope form, I can easily switch this over to the slope-intercept form. Using my distributive property here, I'm going to have y plus 2 is equal to 1/4 x plus 1. And then I just have to subtract that 2 from both sides. And I have y equals 1/4 x minus 1. The exact same thing that we had before. So again, either method works. You decide what works best for you and stick with that. So number 6 is very similar to that. You can check your answers on Blackboard to make sure that you've got the correct answer. And if you work it out correctly, you should have for number 6, y equals our slope of 2/5 x, and then you should come up with the correct y-intercept of -12. So check that on Blackboard, make sure you got it. Number 7, this is one of those where we're given 2 points. So if we're given 2 points, the first thing that we're going to do, and I'll show my work over to the side here, we want to find our slope. So we're going to say -6 minus 4 over 2 minus 2. Well, as I'm working that out, I say, -10 over 0. Remember, that's undefined. So that means that we have a vertical line, which is simply x is equal to, what's our x value that was repeated? 2. Okay, so if you see that an x value is repeated, that's kind of an indicator. You really don't even have to find the slope. You can say, oh, well, both x values were 2. That means I have a vertical line at x equals 2. So kind of be on the lookout for that. Of course, if you forget and you work it out and you see your slope is undefined, that's another way to see it as well. Looking at number 8, if we're passing through an x-intercept of -4 and a y-intercept of 6. You might not think right away that it's giving you enough information, but it is. Keep in mind that x-intercept and the y-intercept are each ordered pairs that tell us what's going on. So for number 8, if our x-intercept is at -4, that means we have the point -4, 0. And then with our y-intercept at 6, that means that we have a point at 0, 6. So I can find my slope by saying 6 minus 0 over 0 minus a -4. Oops, there we go. So we have a slope of 6 over 4, or 3/2. So now I have my slope of 3/2. They told me my y-intercept was at 6. So in slope-intercept form, y equals 3/2 x plus 6, and we're done with number 8. So just using all that information, you can find slope, you can find the y-intercept. There's different methods or different approaches you can take, but you'll still get the same answer. For number 9, we're going to start to increase the thought process here. We want the same y-intercept, or the b value, as y equals 9x minus 5. Well, our y-intercept or b value is -5. And then we want the same slope, or m value, as x minus 2y is equal to 5. Well, if I switch that to slope-intercept form, then that's going to give me -2y is equal to -x plus 5. Well, dividing by -2, that's going to give me y equals a positive 1/2 x minus 5/2. Well, we just want that slope. So we're going to have a slope of 1/2. So that means when we put the two pieces together, we're going to have y equals our slope of 1/2 times x, and then our y value was -5, so minus 5. And we are kind of running out of room, so I'm going to skip a little bit. For number 10, you'll be able to see on Blackboard that you should get the equation y equals negative 7/3 x plus 5/3. So check and make sure you can find the slope in the y-intercept and come up with that equation. For number 11, we definitely want to talk about this one. Write an equation of the line that has no x-intercept and a y-intercept of 7. Well, anytime they're saying no x-intercept, this is our clue that we have a horizontal line. And if our y-intercept is at 7, that means our horizontal line is going to have the equation of y equals 7. No work really involved in that one. Let's look at number 13. With number 13, they gave us two equations. Or not two equations, excuse me, but two ordered pairs. So when we have our two ordered pairs, we want to find the slope. So we're going to work this one over to the side here. So finding our slope, we're going to say 1 minus 1 over 7 minus negative 3. Well, I notice that my y values in this case are the same, giving me 0 over 10. So there's our clue, slope of 0. We have a horizontal line. So that means that horizontal line, we're going to have y equals that repeated y value of 1. Alright, so again, be on the lookout, x or y values that repeat. If the x value repeats, you're going to have an undefined slope. It's vertical, so x equals whatever that x value was. If the y value repeats, that means that you have a horizontal line, and your equation is going to be y equals the y value that repeated. We'll do a few more of these, and then we'll start talking about standard form and how to convert over to standard form if we need to. So if we have a graph like we do on the right here, and this is for number 14, we can see that we have our y-intercept here at 3. So our b value will be 3. To find another point on the line, I can see, oh, I'm crossing right here, and I'm going to go down to the right one. So that means negative 2 over 1, or just plain old negative 2 for my slope. So that means the equation of the line in the graph is y equals negative 2x plus 3. The graph ones are pretty easy. Alright, a couple more and then we'll talk about standard form. If we want a line that is parallel to y plus 2 equals negative 1 times x minus 3 containing the point 0, 6. So that key word there, we want it parallel, so we want the same slope. Well, notice our equation is in point slope form with the y plus 2 equals negative 1 times x minus 3. So that negative 1, there's our slope of negative 1, and we want to contain the point 0, 6. Well, if x is 0 and y is 6, that means my b value is 6. So I have the slope and y-intercept without really having to do anything. Just put the pieces together and say y is equal to negative 1, or just negative x, plus my y-intercept of 6. And there's my equation. If we want a line that is perpendicular, remember slope is the opposite reciprocal. So if we want the opposite reciprocal of y equals 4, and it contains the point 7, negative 3. Well, if y equals 4, that means that we have a horizontal line. So m is 0. So the opposite reciprocal is going to be undefined. Let's say slope is undefined. So anytime it's undefined, we have a vertical line. which means we're going to have an equation in the form of x equals. Well, our x value in this particular case is 7, so our equation is x equals 7. Alright, so that's writing all of our equations in slope-intercept form. Let's look at standard form. We can approach these from the same method that we did before. We just want to make sure that our final answer is in the form of ax plus by is equal to c. So if we're containing, we have a line that contains the points 1, 4 and negative 4, 3. We're going to start out number 18. We'll start up here, make some room. We want to find our slope at 3 minus 4 over negative 4 minus 1. So that's going to give us a negative 1 over, oops, and that was a negative 4 there. Make sure we can see that. So negative 1 over negative 5. So negative over negative, we can just make that a positive. So if we have a slope of 1/5, and then we want to write our equation in standard form. Well, I'm going to start out in point slope form, and I'm going to use the point 1, 4. So we're going to say that y minus my y1 value, my y value is 4, is equal to my slope of 1/5 times x minus my x1 value of 1. So there I am in point slope form. To get it to standard form, remember, we don't want any fractions, and we want our x and y value on the same side. So I'm going to start distributive property. Y minus 4 is equal to 1/5 x minus 1/5. Now some people like to get rid of the fractions first. Some will move your x and y to the same side and then get rid of the fraction. Really doesn't matter to me, but I know most of y'all like to get rid of the fractions, so we'll do that step first. So to clear the fractions, remember, if you multiply by the LCD, then you can get rid of the fractions. Well, all we have is 5, so multiply the entire equation by 5. So that means that we're going to have 5y minus 20 is equal to 5 times 1/5. Our fraction is gone, we're just left with x. And 5 times a negative 1/5, we're just left with the negative 1. So now we want our x and y's on one side, and then we want the constants on the other. Now keeping in mind that we do want our x, or the a value, to be positive. So I'm going to move the 5y to the right side and add the 1 to both sides. So those are gone, and then we are left with our final answer of 19 is equal to x minus 5y. Or if you want it in the other direction, x minus 5y equals 19. And that should be a negative 19. And there we go. So very easy. You can kind of think about putting it into slope-intercept form almost, but we want our x and y on one side, constant on the other. If we look at number 19, I did not leave much room for that, so we're going to put number 19 down here on the bottom. For number 19, if we want a line that is parallel to y minus 3 equals negative 2 times x plus 3. So we can see from there that our slope, we're in point slope form, so we can see our slope is negative 2. And then if we're containing 0, 2, then that gives us our y-intercept 2. So we can start out in the form of y equals negative 2x plus 2. Very easy to move this one. Add our 2x to both sides. So we have 2x plus y equals a positive 2. So we have our x and y on both sides. A, B, and C are all integers, and our a value is positive. So for number 19 in standard form, we have 2x plus y equals 2. All right, just a few more. For number 20, if we're containing the y-intercept of 2x minus y equals negative 4, and if it's going to be perpendicular to y equals negative 2. So if I have y equals, that's a horizontal line, so I want this perpendicular line that's to that, it's going to be vertical. So that means that if I have a vertical line, it's going to be x equals something, and the y-intercept, if it contains the y-intercept to the first equation, we can't see it for sure from here, so we're going to switch it to slope-intercept form, and we'll have y equals 2x plus 4. So we want it containing the point 0, 4. So if we have a vertical line, that means it's going to pass through that point using that x value. So we're going to have x equals 0 for the equation in number 20. All right, kind of getting the hang of those parallel and perpendicular lines, hopefully. Let's look at number 21. If we're passing through negative 9, 5, and we're perpendicular to 6x plus 2y equals 4. Let's work this one down below as well so we have a little bit more room. So we're going to keep in mind that we have the point negative 9, 5. We're going to use that, it's going to pass through that point. But we want it to be perpendicular to 6x plus 2y equals 4. So first we need to see, well, what is the slope so we can find that opposite reciprocal. So let's switch it to slope-intercept form, solving for y. So we're going to have 2y equals negative 6x plus 4. Then dividing by 2, we have y equals negative 3x plus 2. So our slope here is negative 3. We want the opposite reciprocal of that. So that means that we want the slope to be 1/3. And that looks not like the word so, our slope, so we'll separate it there. So our slope will be 1/3, and then we want to pass through that negative 9, 5. So I'm going to put this in point slope form and then change it over to standard form. So we have y minus our y1 value of 5 equals our slope of 1/3 times x minus our x1 value of negative 9, so x plus 9. So to get this into standard form, I'm going to use distributive property first. Y minus 5 is equal to 1/3 x plus 3. And then I'm going to go ahead and get rid of the fraction by multiplying everything in there by 3. So that means that I'm going to have 3y minus 15 is equal to 1x plus 9. So I'll move everything around. If I move my x over here and then add my 15 here, keep in mind if you're working it out this way, you want to be very careful. Negative x plus 3y is equal to 9 plus 15, which gives us 24. Now you want to watch out because that negative in front, we're not in true standard form. So if we multiply everything by a negative 1, then we'll have our standard form x minus 3y equals a negative 24. And there's our answer for number 21. All right. Then for 22, passing through 0, 5. Hey, I like it when it does that because there is my b value of 5. So I'm getting my y-intercept from passing through that point, which is the y-intercept, and then we want it to be parallel, so same slope, as negative 4x plus y equals 12. Well, I'm not in slope-intercept form there or point slope form, so I need to switch it real quick, and that's going to give us y equals 4x plus 12. So I want that same slope of 4. So this one isn't too bad. I can see that I'm going to have y equals 4x plus 5. And that is for number 22. but that's not in standard form, is it? So we want to put that one into standard form. Not too hard to do. We're just going to move our x over with the y, and that'll give us negative 4x plus y is equal to 5. But again, we don't want that negative out front, so we're going to multiply everything by negative 1. So our a value is now a positive 4x minus y equals negative 5. And there is our final answer for number 22. All right, and I'm only going to work through one of these that are from a graph. Again, you can check any of these answers on Blackboard, including your homework. We can see from our graph that we have a y-intercept at 1. We can pick another point here and see we're going down 2 to the right 3. So our slope is negative 2/3. So I can write my equation as y equals negative 2/3 x plus 1. I'm going to go ahead and get rid of my fraction first, multiplying by that denominator of 3. So I have 3y equals negative 2x plus 3 if I distribute to everything in the equation. And then all I have left to do is to add that 2x to both sides, because that is going to give me a positive a value. So I'm going to have 2x plus 3y is equal to 3. And I am in standard form. A, b, and c are all integers, and a is positive. So there's our practice writing in standard form. Tonight for homework, you can choose evens or odds. Doesn't matter to me, but you're getting practice with 10 equations writing in slope-intercept form for some of them, standard form for others. Be careful, follow directions, see what information is given, and decide which method to choose. Again, you can email or send me a remind message if you have any questions, and I will see you in class.